The last part of Learning Target 7.2 here. So we've done simplifying exponential expressions. That's the E stuff that we did, you know, how we simplified it with the exponent rules, that sort of thing. Okay, so simplifying the exponential expressions with E. We've solved equations. We just got done doing that. A couple examples where you had to solve for X, right? Okay. And the last part of it is writing exponential equations. Okay, writing exponential equations. Well, if you go back to 7.1, I kind of have taught you that every exponential equation, you know how every linear equation is y equals mx plus b? What are exponential equations? Y equals
A times b to the
good. Y equals a times b to the x power. Okay? So that's what your answer is going to look like, except you're actually going to figure out what the a value is and what the b value is. Okay? So your answer will look like this, but you'll have numbers in there for a and b. Okay? So here's the type of problem you're going to see. Okay? It's going to say, write an exponential equation that passes through, and then they're going to give you a couple coordinates. And see, I'll pick 2, 8, and 3, 32. Okay. So I'll give you a couple coordinates here, and I'm saying there is some exponential equation that passes through those two coordinates. We got to figure out what that equation is. Right? Now, some of you, if you're pretty good with numbers in your head, you might be able to determine what the A value and the B value are pretty quick, especially for this one because it's a pretty simple one. Okay? But I'm going to show you the algebraic way to do it first. Okay? All right. So, 2 and 8. That's an x value and a y value, right? So I'm going to take this and plug it in for x. I'm going to take that and plug it in for y, right up here. Okay? So 8 equals a times b raised to the second power. Everybody see what I did there? I'm going to do it with the other one over here. 32 equals a times b to the third power.
Why'd you go from b to the second to b to the third?
I'm using this coordinate again, Paul.
Is the first number is that always the exponent?
Yeah, x.
Oh,
Yep.
Okay.
Yep.
That makes sense.
Yep, that's right.
Is the a value for this 2?
Nope.
No.
Almost.
Oh,
It's a half.
it's a half. Okay.
Gotta go back one more. If I'm, and maybe we're not on the same page.
Yeah, no, I get
Okay. And I'll talk through that here in a second. Like I said, this one you can kind of calculate mentally, and I'll tell you what he's doing mentally here in a second to try and explain it, but some of the ones might not be as easy to do, so I want to show you the algebraic way, because otherwise guessing and checking or trying to figure out might be a little bit tricky. Okay. All right, so I got two equations here, and I got to solve for a and b. All right, well, this kind of goes back to Algebra 1 a little bit. All right, if you got two equations with two different variables in it, you're going to use one of the equations, get a variable by itself, and substitute it into the other equation. Okay? So what I'm going to do is I'm going to go ahead, I'm going to get this a by itself right here. How do I get a by itself in this equation? Divide by b squared, right? Okay? So I divide by b squared, divide by b squared. Okay? So now I have a equals 8 over b squared. Well, because a is equal to 8 over b squared, I can take 8 over b squared and substitute it in for this a, right? That's what a is equal to, so I can substitute in. Logically, that makes sense?
Yep.
So 32 equals 8 over b squared times b to the third. When I take 8 over b squared times b to the third, what will you get? 8b. Because when you got a b squared in the denominator, and really this is b cubed, essentially you could even think of it as over a 1, right? You got a b cubed on top, you got a b squared on the bottom, 2 of the b's cancel out and you're just left with 1b on top, so you got 8b. Yes? So 32 equals 8b. If 32 equals 8b, what does b equal? 4. So now I know b equals 4. And if I know b equals 4, could I substitute that back in somewhere to solve for a? Yep. In fact, you could probably do it right here, right? A equals 8 over b squared, right?
Mm-hmm.
Well, what's b? What's 4 squared? 16. What's 8 over 16 reduced to? 1/2. So a equals 1/2. So a is 1/2, b is 4. Can I write my answer? What's it going to be? Y equals 1/2 times 4 raised to the x power. Okay? And then if you want to, could you check? Could you plug in 2 for x and hope that you get 8 for y? Could you plug in 3 for x and hope that you get 32 for y? Yep, that's what I would probably do. Okay? Now, the way you can think about this one mentally a little bit is, remember in exponential functions how you're always multiplying by the same number over and over and over again? These two coordinates, essentially they're right next to each other if you made a table of values, right? 2, 8, 3, 32. What did we multiply by to get from 8 to 32? 4. So there's your b value already. You can do that because these are right next to each other. If they were a little further ways apart, you have to figure out what multiplies by that many, by a number so many times to get to that one, which makes it a little tougher. Okay? So the b value is 4. Well, the b value is 4, let's work backwards. 32 to 8, so then it must have been 1, 2, and then 0, 1/2. So 0, 1/2, so therefore 1/2 would have to be the a value. Okay, so you got to work backwards in your mind. You got to figure out what you're multiplying by over and over again. It can be a little tricky. Algebra works every time. Don't have to kind of do as much mental math. Just logically plug in what makes sense. Okay. We'll do one more of those. I want to find one that's how's my time on the video?
You're at 8
8
minutes.
8. Okay. So let's say I got an exponential equation through one comma 80 and 4 comma 5/4. Hope I did this right. Okay, so this one's probably a little bit more tricky to figure out what you're multiplying by because the two coordinates I gave you weren't right next to each other, right? Okay? Alright, so let's do it algebraically. What do we write? 80 equals A times B to the first power. And then what else will we write? write your two equations, 80 equals a times b to the first, or just a times b, and then 5/4 equals a times b to the fourth. Everybody good with that? Then what do you do?
Solve for one of them.
Solve for a variable. Solve for a, solve for b, doesn't matter. Got a preference? What do you want to solve for? I would say one of these variables would be easy to solve for in this case, right? The a or the b, doesn't matter. What do you want to solve for? I'll solve for the a. Okay, well, how do I get a by itself here? Divide by b. So a equals 80 over b. Then what are you going to do with 80 over b?
Substitute.
Substitute it in over here. So 5/4 equals 80 over b times b to the fourth. Well, what's 80 over b times b to the fourth going to equal? 80 b to the third. Yep, 80 b to the third. So 5/4 equals 80 b to the third. Now this one's going to take a little more work, but isn't bad. Solve it for b. Divide by 80, and then how do you get b cubed down to just b? Raise it to the 1/3 power, or cube root both sides. Okay? Need a little help here, guys, on the calculator. Okay? So divide by 80. That'd be, I can do that. I think that's 5 over 320. You probably have some decimal. Okay?
Yeah, that's it.
1 over 64.
Yeah.
Oh, for this? Yeah, that would reduce to 1 over 64. Yep. Oh yeah, that would make sense. So if b cubed equals 1 over 64, then you need to cube root both sides, and you get b equals how much? 1/4. Okay? You got to cube root both sides to get b by itself. So then you have 1/4 equals b.
Plug B back.
And then plug b back in. $80 divided by 1/4. $320. So A would equal 320. So my final answer, y equals 320 times 1